Welcome to the possibly last, I should say hopefully last and third YouTube video on the COVID-19 spread. If I can ask the camera person to kind of kindly focus on the mathematics again, once again. Uh, if you have watched, and I encourage you to watch because it's really, really cool, watch the previous videos, we had a model for the spread of COVID-19 in Canada or anywhere in the world. We have assumed that the disease will last for 21 days, and capital of P of T is the total amount of people infected up to now that are infected or have been infected up to this point. The rate of infection then, the spread of this rate, is proportional to this R value, which is how many people are infected by a person in a day. We're going to choose a R value of 1 over 12, where we tend to have the following scenario, that one person will infect, so I should say like this, in 12 days, one person will try to infect one person. If that infection falls onto a susceptible person, who knows, but the attempt will be one attempt in 12 days per person. So obviously the rate of infection is going to be proportional to this R value, to total amount of people infected up to this point, times a mitigating factor. This factor, this bracket, tells us the probability that the infection will hit a person that has not been infected yet. This is for the duration of the first 21 days. Anybody who has been infected up to this point is contagious. After 21 days, however, that changes. The R value is still the same, but the pool of contagious folks is being reduced. It's the difference between the total infected people up to now minus the people that have been infected 21 days ago. So that gives us the contagious pool of people that are capable of infecting, and the bracket stays the same. That's the probability that the infection will land onto a susceptible person. So based on this model, we're gonna do a computer simulation with some specific values now. I think it's about time we put some specific values. So aside of the R being 1 in 12, we assume that the initial infection of folks at the beginning of the pandemic was 1,000 people. So the the amount of people infected at the beginning is 1,000 people. So if I can ask the camera person now to move to a computer, and we'll take a look at the model. This is quick. So if you could kindly focus on this graph so folks can see the graph here. This is the graph of the expectations of people that are unfortunately going to die from the disease. COVID-19 has a fatality rate. There is up to this point still discussion how much. So what I'm going to assume in this model is, what if it is the kind of the bad expression, business as usual influenza strain? So I would assume then under this scenario that 1 in 10,000 people will unfortunately die from the infection. Based on this, again, R value of 1 in 12, which is pretty severe restriction in movement in Canadian society. When you think about it, one person will try to infect 12, unintentionally of course, 1 person in 12 days. So what we're going to obtain with the death rate of 1 in 10,000, we're going to estimate that when the pandemic is over, we would kind of expect to have 3,000 unfortunate fatalities overall during the pandemic, and we would obtain the max rate of fatalities, which would occur about 6 months later after the beginning of the pandemic, and the max rate would be expected to be about 35 people per day. Do notice on the graph that it becomes very gradual arrival to the 35 people per day maximum. For the first month, you don't see much. Second month, you might have few, 1 or 2 or 3 deaths per day, maybe even less. And then after about 2 to 3 months, it picks up very quickly, reaches that 35-ish people per day, and then it fairly quickly dissipates, the same way that it went up, same when it goes down. To wrap it up, this was an attempt to what we would expect if this pandemic was actually business as usual influenza strain. How many people we would expect, unfortunately, to die from this disease? The choice of 1 in 12, there is nothing specific about that. I have chosen 1 in 12 because I had to choose something, an estimate for the restriction that we are putting into our societies. Maybe it's less, maybe it's more. And so these results will be a little bit different, but fundamentally it gives us an idea what to expect. Hopefully this was the last one, so I don't bore anyone anymore. Thank you very much for your attention. Bye-bye.